Hey everyone, welcome back to this channel. In our last class, we understood how to convert any dataset into a data frame so that model can be applied on the data frame. But before applying any model, we have to understand the data. Or we can say we have to explore the data. We have to inspect, we have to clean, we have to transform. Then only we can apply modeling on the dataset. Okay, because the data may be not in the proper format. The raw data may be messy, may be dirty, may be not cleaned. You may need some changes on the data set. So you have to understand what is the types of data, types of column. You have to understand the hidden pattern. You have to find the insights. So all these things comes under EDA part. Simply we can say exploring the data. So why is EDA important? We have understood that we have to understand the data. We have to identify the relationship, the correlations between variables. What is the trend? What is the potential relationship between different features or columns? Whether there is any missing value, whether there are some values which are very much different from the mean. That means if any outlier is existing in the data set or not, or which features are most important for my model, which features are not so important. That means any features we can remove before modeling the data set, feature selection, or we can say feature engineering, or extracting data from any features. So these are the various techniques we can apply on a data set so that we make our data set ready for modeling. So you get my point. EDA is a part where you understand the data, clean the data, and make it ready for modeling. Fine. Now the basic 6 steps of EDA: discovering, structuring, cleaning, joining, validating, and presenting. Let me tell you one thing. Are no fixed rules. It's not like that only after discovering you will structure. Only after structuring you will do cleaning. Nothing like that. After you do cleaning, you may validate the data. After you validate the data, you may need some joining. After you join the data, you may need again validating. After you validate the data, again you may think that I need some type of structuring or I need to know more about the data. Okay, so no hard and fast rules for doing ADA. It's like trying out any new recipe. Just before you try out the recipe, you check whether the vegetables are rotten or not. Then only you try out the new recipe. Same here, just before the modeling, you make sure that your data is properly ready. Okay, so this is known as EDA, and in our next class, we will start discovering how to discover any new data set. Okay. We will familiarize ourselves with the data so that we can understand how to use that data set. Fine. So meet in our next video. Till then, bye. Happy learning. Hello everyone. Welcome back to this channel. Let's continue our EDA session, Exploratory Data Analysis, where we explore the data. So our first step is discovering the new data set. So we have to understand the context of the data. We get familiarized with the data. Then only we can think how we can use the data set. Fine. Now let's do some discovering. Okay. First, First, I have downloaded all these libraries. We have studied about these libraries in details. So, NumPy, Pandas, Seaborn, and Matplotlib for visualization purpose. And there is a dataset named Penguin dataset that is already in Seaborn library. So, I have just downloaded it. Let me show you. If I write df, okay, you can see this is the dataset. Now, I want to know about the dataset. Firstly, if you want to know, you can simply open the dataset and you can just check manually, or if you want you can write some code to know more about the dataset. So first I will write df.head. If I want to know about 5 rows from the dataset, first 5 rows from the dataset, then df.head. Giving nothing means first 5 rows. 5 is the default value. If I give 10, then it will show me first 10 rows of the dataset. So you can understand what is there inside the dataset. What are the column names? What does this column means? Okay. Now if you want to see that last 10 rows from the dataset, you will simply have to write df dot tell 10. 10, 15, whatever you want to see, you can give. Okay. Now I want to know in details. I want to know df.info. So it will give me complete information about the dataset. Let's see. Here you can see 344 entries. So there are 344 rows. Total 7 columns. And here you can see the column names. Not null. So you can see 344 values are present. There is no null value. But here 342 values are present. That means 2 values are missing. Okay. You can understand what is the data type. D type. This one is object. Object means string data type. Float. Float, bill length, bill depth. Here also you can see these are the float values. Again, sex is an object data type. So you get an overall idea about the data set, right? Now if you want to know the size of the data set, so you can write df dot size. Size is an attribute. Attribute means you don't have to give any brackets because this is not a method. Then it will show an error. Oops, concept, object oriented programming concept. Total 2408 values are present. If you add all these numbers, then you will get this value. Okay. If you want to check how many rows and columns, then df.sep 344 rows, 7 columns. Here also you can see 344 entries, 7 columns. Okay. So you are knowing about the data set. You can also write df.describe. It will give you some statistical measures of the numerical columns. Let me run it. See, mean value 32 is the minimum bill length, maximum value 25 percentile, 75 percentile, 50 percentile. That means the median value, middle value is lying here. This is the standard deviation, mean value. How many values are present? 342 total count. Okay, so you can see that 342 values are present. 2 values are missing because there are total 344 entries. Okay, so you understand about the data. Now see here, this will give you value for the numerical columns because this cannot be applied on categorical columns. So automatically it finds the numerical columns from the dataset and gives all these measures. We have studied about these things while studying descriptive statistics. I hope that you have idea about all these things, about percentile, about 5 number summary, about all these things, about 5 number. I hope you have idea about all these things like minimum value, maximum value, percentile, the 5 number summary. Okay. Let's do some more. If I want to check null values, dot each null dot sum, it will give us the count of how many null values are present. See here, in spaces, no null value, island, no null values, but bill length 2, because you check here, total 342 count, 2 values are missing in every column. See, 2 values are missing. In sex, 11 values are missing. Okay. Now, before applying modeling, you have to work with these things. Like you may remove them, you may replace them by forward fill or backward fill, by mean value or by median value. So, depending on your project and your aim, you may work with this missing value dataset. Okay, but first you have to know whether there is any missing value or not. This comes under this discovering part. Okay, we can also check df dot d types. Now, see if I run it. See the data types. The species, string data type, island, string data type. Before visualizing them, you have to understand what types of data we have. Sometimes we may need to convert categorical data into numerical data. Because for machine learning, you may have to convert the categorical to numerical data. Okay, so first you should know what are the types of data you have. If you don't know about these types of data, numerical or categorical, I have a video on that I have described in details. The simple topic. When there is a number, numerical data, when there is a category, string category, then you can see this is a categorical data. Okay. Now what are other things we can see? Like if I write df dot columns. See, this will give you the column name, species, island. There may be some typing error in any column, or if you want to change the column name, maybe you think that this is a big name, you want to change it to BLM. So you can replace that. Okay. So this way you can change your data set, or I can say you can modify your data set. Fine. Now let's say I want to know DF. I want to know about average wavelength. So I can simply paste it and dot mean. Or see, so they have this mean wavelength. Okay. If you want to know median, just let me copy. What is the median value? 44. So mean value is, and median values are almost equal. If there is a difference between mean value and median value, then the data may be skewed, maybe positively skewed or maybe negatively skewed. So that time you have to make the distribution normal. Okay. These things we will learn while doing project, that how we have to make our data ready. But before that, you must have this idea. Then only you can understand what are the things you need to do. Okay. Or if you want to sample, we did sampling. You remember we did a complete class on sampling. Suppose I want 10 sample values from this data set. Oh, I'm so sorry. Just write sample. The technique is known as sampling. Okay, so it will give me 10 random values. If I want, give me 4 sample. Head will give you the first 5 rows. Tail will give you the last rows. But I don't want first or last. I want random rows. So I can use sampling from the population. If I run it again, then another numbers will be generated because random numbers. Okay. So these are the way we can discover a data. Let's do it on another data set also. I have a data set, Amazon book sheets, copy path. I have downloaded this from Kaggle. Okay, Kaggle, let me show you. Kaggle is where you can find data sets. Just uh, create your account if you don't have. Then you can download any data set and then you can apply different kind of discovering techniques. You try to understand the data set. Okay. Anyway, let me make it a data frame. I write df1 equals to pd dot. You tell me what will be the code. It's CSV within quotation. I have to paste this the path. Now just df1. It will show you the data set. Fine. Now if you want to apply df1 dot head, it will show you first 5 rows, right? If you want tail, last 5 rows. Okay. Info, it will give you complete information. Sorry, this one is info. df1. So you can see that there are 7 columns, total 600 entries. Column name, author, user rating, reviews, price, year, genre. This dataset is about books in Amazon. Okay, so this dataset is about books and authors. Okay. Now if you want, you can check how many categorical values are there, how many numerical values are there, whether what is the D types. Let me show you. It will show you the data types. Okay. If you want to explore any categorical value, suppose it is a genre, I want to know what types of genre are there. So I have to write df genre dot value underscore counts. Now if I run it, uh, what is the name? Sorry, df1. See, there are non-fiction 337, fiction 263. Okay, so you can understand that whether the data is balanced data set or imbalanced data set. Balanced data set means both have similar number of values, almost similar, but non-balanced means maybe non-fiction is too much than fiction. So here the data set is okay types. So you can understand this also. Okay, in Penguin data set also you can, first let me run this. You can know the species types. So you have to write df species dot, sorry, dot value underscore counts. You can understand 3 species type. Okay. So this way you can explore the data. Fine. Or if you want to know more, let me write df or df1. If you want to know the mean price value, so we can write price dot mean value. Average P maybe in caps. Exactly. So average price value you will get from here. Or if you want to know like types of author, let's do this. You have to experiment here simply. Sometimes you will get some values, some meaningful. Sometimes you will not get. But you have to explore as much as possible. In later classes, we will understand how to start exploring. But here we are just seeing what are the types of exploration we can do. You can find many number of authors. Okay. Jeff Kinney has written maximum number of books. Okay, next. We can see which books have received 4.8 user rating. So we can write user, so we can write user rating, user rating greater than 4.8. Now if I run it, I have to filter it. So I'll write df1 and here also close the bracket. Then I will get only those which are true. See, greater than 4.8. Is there any book got 5 ratings? If I write 4.9, greater than 4.9, no, nothing, no books. So greater than 4.8, 61 rows, 7 columns. That means 61 books have got 4.9 rating. I can also check if there are any duplicates. So I can write duplicated. If I run it, see, I will get this one. So I just write sum. And it will give me the total. No duplicates value. Let's check for df1. There is also no duplicated value. If there are duplicates, then you have to remove the duplicates. Otherwise, it will create bias. So you get my point that here we are just discovering the data. And if you want, we can simply open the data set and see here. We can just see from here also. Name, author, user rating, reviews. You can just scroll and manually can understand that the types of data. Okay. So you can understand that our first job is to discover the data in different ways. Okay. Now in our next class, we will do some structuring in a dataset. Okay. We'll meet in our next video. Till then, bye. Happy learning. Hello everyone, welcome back to this channel. Let's continue our EDA session. In our last class, we understood how to discover the data, how to get familiarized with the data, and how to initially explore the data. Okay, in this class, we are going to structure the data. Maybe your raw data needs to be structured. Maybe you need to sort the data. You extract some information from the data. You may need to filter the data, slice the data, or group the data. All these things comes under structuring part of EDA process. Let's understand all these things in details. Okay, first I have taken two data sets. See here, two dummy data sets. On these data sets, we are going to apply all these methods of structuring. Okay. Now first one is sorting. Sorting, you know that arranging data in a meaningful order. It may be in ascending order, it may be in descending order. It must have some meaning. Okay. You may need to do these types of sorting while doing EDA part. Let's first convert this data set into data frame. So first one I want to give df equal to pd dot data frame data one first data, second one copy paste. I'll name it df1 and this one is data1. Okay. Now let's do sorting on the first one. First let's see how it looks. The dataset is about a student data, student name, subject and their grades. I want to sort this grade in ascending order or in descending order. So how can I do this? First give it a name, case underscore df equal to df dot sort underscore values, and here you can write by equals to grade or you can simply write grade. Then it will be sorted, but let me show it to you. By default it will be sorted in ascending manner. If you want to change it, then you have to write ascending equal to false. Then the highest number will appear at the top. Now see, sorted in descending order. Okay, this is simply sorting. Now let's do some sorting in this dataset. Let's explore the dataset first. df1. See, this is the dataset. You have order ID, product name, how much quantity you have ordered, price, order date, purchase address. Now do you remember how we can see number of rows and columns? If I write df1 dot shape attribute, shape is an attribute, not a function. Okay, so you can see 6 rows, 1, 2, 3, 4, 5, 6, 6 columns. Okay, if I want to know the size, then df dot size, so it will be 6 into 6, total 36. Sorry, not df1. Okay, let's do sorting. Okay, today's class is mainly on structuring. Suppose I want to sort it by price age. So how can I do it? Df dot sort underscore values, and you can write price age, not df1. Okay, so you can see it is sorted. If you write ascending equals to fall, then 1700 will be at the top. So MacBook Pro is the costliest one. Okay. Now suppose I want to know the total revenue in ascending order. So first I have to calculate the total revenue. Let's calculate it first. Total revenue. This is the name I am giving it to. Now it's DF. How to calculate this? By price into quantity order. So DF quantity ordered into DF price of each. Now if I run it, uh, again it's DF1, it's DF1, it's DF1. Okay. Now I have got a new column in this data set. Let me show it to you. When it doesn't show you the output, that means it has been changed permanently. See, DF1, total revenue. Okay, this may sometimes create confusions. If you can see the output, that means the change is temporary. But if you can't see the output, the change is permanent. Okay, this is just a kind of trick. You have to keep it in mind. Otherwise, you may face some unnecessary error. Okay, anyway, we have got a new column, that is total revenue column. Now I want to sort this total revenue column. Okay, now I write df dot sort underscore values sort by total revenue. Okay, now if I run it, uh, please forgive me, df1. Okay, now suppose I want to see in ascending equals to false. Now see, MacBook, very natural. MacBook has the highest revenue. Okay, so you first calculate the revenue, then you can sort it. If you want, you can sort in quantity orders also. You want to say that which product has been ordered the maximum times. Okay. So these are the things we can do from sorting. Now our next is extraction. Extraction means the process of retrieving data from a data set. Now see, in this data set, we have city inside the purchase address. So I just want the cities only from this purchase address column. Okay. So I can create a new column named city, and there I can store only the city names. So I am extracting a value from this data set. Okay. Okay. Now df1 city, new column name. So first I have to take the purchase address column. So I will take purchase address. Okay. Now I will apply a lambda function. Lambda is an anonymous function. I hope you know, we studied while studying Python. So X, here I will do split. I'll split the column. This complete one, I have to split it on the basis of comma. So here I have to write comma. So it will be splitted based on comma. This one will be at 0th position. San Francisco will be at 1st position. CA will be at 2nd position. So now I want only San Francisco. So I have to write 1. Okay. Once I am done, I have to strip. Okay. Now let me show it to you. Let's see DF1. No output, that means it has been changed permanently. See. So I have got a new column in the data set. Here, San Francisco, New York, Los Angeles, you can see that city has been extracted. This is what is known as extraction. Fine. Now let's do one more sorting on this data set. I have got the city column. Now I want to sort by city, then by price each. Let me show it to you. df1 dot sort underscore values by uh, city, comma, price each. Okay. Now comma, even ascending order. First one, I want to be true. Next one, I want it to be false. So what will happen here? First, let me write the code first, comma, false. Okay. First, city will be in ascending order. First will be Austin, then Los Angeles, then New York. So it will be sorted alphabetically. Ascending equals to true. Next one, price each, but price each column is in descending order. So the maximum price will be on the top. Now let me run this. Okay, so you can see that first city is sorted in ascending order. Austin, Los Angeles, New York, San Francisco, San Francisco. Because city is in ascending order. Then price is in descending order. So you can see the price. Um, San Francisco 1700, then 11.95. So price is in descending order, but the city is in ascending order. Okay, so you can sort multiple columns together. Okay. Okay, so we have understood what is extraction. Extracting the city from a column. You can extract something else also. And extraction also comes under feature engineering, but I will create a complete separate class on feature engineering. Today's main focus is on structuring. We have extracted dataset and we have sorted the dataset. Okay. Now let's understand what is filtering. Filtering is when you select a smaller part based on some specific parameter, based on some specific condition, given condition. Okay. Now suppose I want to filter only those products where quantity ordered greater than 1. So I can write df1 quantity ordered greater than 1. I want only those data. Now if I run it, it will give me boolean values. So I have to do boolean masking, then it will give me only those values which are true. Now if I run it, see here, only those quantity, only those products where quantity ordered is greater than 1. So 2 and 3. Okay. This is known as filtering. So you are filtering the data based on some condition. If you want, you can filter based on total revenue. Like I want only those rows where revenue is more than 700. Okay, so you have to write DF1 total revenue greater than 700. Fine. I want only those orders which are from San Francisco. So I have to write DF1 city equals to San Francisco. Let me show it to you. If I write DF1 city equals to San Francisco. Now see if I run it, you can see. So I have to pass it to the data set. Then only those values which are true. What happened? Oh, I'm sorry. There is a gap. That's why it could not match anything. Okay. 23 and 1700 cable and MacBook Pro. Fine. So you can filter the data simply based on any condition. I want only those products where the product is iPhone. So I can simply write df1 product equals to iPhone. Okay. Now let's boolean mask it. So df1 and this is a string, so I have to give quotation. Now if I run it, fine. Let's extract only those orders which are from 15th January to 17th January. Okay. Now for that, first we have to check the data types. Let's see the data types first. See here, order date is object. So I have to convert it to a date time object. Now let's do it first. df1 order date equals to pd dot to date time df1 order date. Okay, now this data type will be converted to date time object. Let me show it to you again. Dot d types. D types means data types. We understood this while doing discovering part. Okay, now it is fine. Now I can apply our condition. So I have to write df1 order date greater than I want from 15th January. Let me show the data type, the data set once again. So here, so this is the format 2023 1 15. Okay, and close this first. Next, df1 order date less than 18. Fine, close it in a bracket. Fine. Now again, df1. So I want only those orders greater than 15th January and less than 18th January. Okay. Now if I run it, why is it showing error? Mm, this one is a date time object. So I have to keep it inside comma. Here also I have to provide a quotation. Now if I run it, see, you can see the order date greater than 15. If you want 15 to be included, you have to write less than equal to. Same here. If you want 18 to be included, you have to write less than equals to. Okay. So then you can filter the data set, extract the data set based on some condition also. Okay. In fact, from our first data set, let me show you. If you want only those grades which are more than 80, so you can simply write df grade greater than 80. Fetch me only those data. So you are extracting the data based on some condition. Okay. Now next one is slicing. Slicing is like breaking down into smaller parts. You can slice row wise, you can slice column wise. Let me show it to you. Suppose I want only Bob and Charlie. So I can write df dot ilock. I want from 1 to 3. So 1 and 2 will be included. The last one is not included, you know. ilock, by providing this function, you can extract row wise. Okay. Now suppose I want only student name and subject. I don't want grade. Then how can you slice? So I have to write df dot lock, and here I want all the values from student name column and from grade. Okay. Now if I run it, see, I don't want grade. I want subject. So grade will not be there. Fine. All the values from student name and subject. So you can slice row wise, you can slice column wise. Now I want to slice by both. I want Bob and Charlie, student name and subject. Okay. I want only these four numbers. So I have to slice row wise. I have to slice column wise also from the data set. This is the data set. I want Bob, Charlie, science, math. Okay. This is my aim. So how can I do it? I have to write df dot log here 1 2 3 comma student name subject. Now let me run 1 2 3, that means 1 and 2, these two rows. Then you specify the name of the column, student name, subject. Okay, 3 is included here, so if I don't want, then I have to give 2, 1 to 2. Okay, fine. So you can slice row wise and column wise together. Fine. Now, if you want to slice based on some condition, let's see the DF1 dataset. Now see, I want to slice based on some condition. I want only those products where ordered quantity is more than one. Okay, but I don't want all the column information. I want only product, only quantity ordered. So my output will be USB-C cable, quantity ordered 2, lightning cable, quantity ordered 3. Because these are not more than 1, so this will be ignored. Okay, and I don't want any other column, only product and quantity ordered. So I have to write df1 dot log df1. What is the condition? Quantity ordered greater than 1 exactly, comma, I want two columns. Product, comma, I want quantity ordered. Okay. So I want two columns, but for only those values where quantity ordered greater than 1. Okay. Now, now let me run this. See here. So product, quantity ordered, as we said, USB-C cable 2, lightning cable 3. Okay. So you can give any condition and then you can fetch particular columns. Okay. You if you want you can add some more columns. Like I want a city column also. You want to know from which city it has been ordered. So I can write city. Now let me run this. See. Okay. So you are not getting every columns, not every rows. You are giving some condition and you are extracting the features. Okay. So we have understood sorting, extracting, filtering, slicing. Things overlap with each other. Now next one is grouping. The last one for today's class. Okay. Now let's do grouping. First let me show the first data set. Now what is grouping? Grouping is aggregating individual operations into groups. Suppose I want to group by subject wise. So I want the output to be math, science, English. Okay, then I will calculate the average. So for math, 85 plus 78 divided by 2. For English, 88, single data. For science, 95 plus 92 divided by 2. Okay, so I am first grouping the subject wise, math, science, English. Then I am trying to calculate the average of each subject. Okay, so for this, I want a method called group by. So I have to write df dot group by. Here inside you can write subject. So I want to group by basis of subject. Then I want to calculate the mean on grade. Grade dot mean function, you know, it will calculate the average. We studied in descriptive statistics. See here. English single column, that's why 88. All other columns have been averaged. Okay. So group by is very much helpful and going to be used a lot. Now let's do some group by on DF1 dataset. Let me show it to you first. Okay, so on this dataset, what can we do? We can group by total revenue by product. Okay, so I can write DF1 dot group by. I want to group by total revenue by product. So first I have to write product, then uh, total revenue. Okay, so see what happens. Let me run it to you first. Sorry, dot sum. Now see, product, Apple Watch, Lightning cable, MacBook Pro, ThinkPad, USB-C cable, iPhone. All the products are grouped and then total revenue of all the product. Okay. Now if you want the average price by product, then same. I just have to write here product, but I want average price. So I have to write price each column and then average it, mean. Now if I run it, now suppose if I write reset underscore index, then so it will look better. Okay. Apple Watch, Lightning cable, MacBook Pro, USB-C cable, and iPhone. Okay, so we can group by in this way also. Now suppose I want total quantity ordered by city. Let me show it to you. How can I do this? df1 dot group by city. I want total quantity ordered. What is the column name? Quantity ordered. So write quantity ordered. Total, I want the total value. So I have to apply sum function. Now see. From Austin, 1 ordered. From Los Angeles, 3. Just write reset index. It will look better. See, from Austin, 1 order. Los Angeles, 3. New York, 1. San Francisco, 3. Seattle, 1. Okay. Or if you want total orders by date. Now let's say I want to know total orders by date. So I have to write df dot group by inside this df1. Sorry, df1. So inside this df1, I want order date. So order date. From this, I want to fetch the date only. So dt dot date. Okay. Now if I run it, it is an object. Order date object is created. Now on this, I want order ID. Now if I run it, fine. I want to count the order ID. How many order have been placed? I have to give a dot here. Okay. Now if I run it, okay. So just uh, do reset index. Now let's see. Okay, so you can see on 15th January, 1 order has been placed. 16th, 1 order. 17th, 2 order. 18th, 2 order. So order ID 1 on 15th January, 1 order has been placed. Quantity order 2, but the order ID is 1. 16th January, order ID is 1. 17th to 18th 2. So 17 to 18. Okay, so you can see that order ID on order on any particular order date. Okay, let's do one more. Now my question is to know the total revenue as per the city. I want to know what is the revenue in San Francisco, what is the revenue in New York, what is the revenue in Los Angeles, what in Austin, and what in Seattle. So I have to group by uh, total revenue by city. So I have to write df1 dot group by df1 dot group by. I want to know as per the city. Okay. So here I have to write total revenue. On city, I want to know the total revenue. So I have to calculate sum. Now let me run this. See, city wise, I have gotten the revenue. Okay. So if you write reset index, it will look better. Look like this one. Okay. So this is what is it? Group by. Fine. In last class, you understood what is discovering, how to discover the data. Now you can find so many informations from the data and you can structure the data. Okay, so we will continue our EDA session. Meet in our next class. Till then, bye. Happy learning. Hello everyone, welcome back to this channel. Let's continue our exploratory data analysis. As of now, we have completed discovering, that means exploring the dataset, structuring, that means organizing the dataset. Okay, now today we will understand data cleaning. Whenever you gather any dataset, most of the times it will be uncleaned. So first we have to clean the data, then only we can make it ready for modeling. Okay, now your unclean data can be of two types. Let me show you. It may be dirty data or it may be messy data. Okay. Now what is the difference between dirty data and messy data? Dirty data means when your data is inaccurate. There are some errors in the data set that is incorrect, misleading. Then we can call it a dirty data. But messy data means maybe the data is technically correct, maybe the data is accurate, but the data is not in a proper organized manner. Then that data is called as messy data. In both of the scenario, whether dirty data or messy data, we have to clean the data set. Okay, now first we will understand when we call it a dirty data and what are the types of messy data. Later, we will understand how to clean this data. Okay, so as of now, just have a basic idea about the differences between dirty data and messy data. Okay, so first understand when we call it a dirty data. If your data set has duplicate entries, duplicacy means multiple entries of the same data point. Maybe it's done by any mistake. Okay, or there may be some reason. But whenever you model your data, you have to remove these duplicacies. Otherwise, it will create a bias. Okay, now how to remove these duplicates, we will understand later. But first understand what are the things we need to do whenever we get any data set which is not cleaned. Okay. Next step is incorrect data. The values may be wrong. Values may not make any sense. We need to clear that incorrect data. We have to make the data correct. Next one is outliers. Outlier means when the data points are significantly different from others. Let me give you an example. Suppose in you have a column called age. In the age column, you see that most of the values are lying between 18 to 35. Now suddenly you get one value that is 95, or you get values like 6 months old. So you can easily understand that these values are not so normal. These are far from the mean value, far from the average value. So you may call it an outlier. And it is very necessary that if you remove these outliers before you model your data. Fine. Next is your data may be missing. You may have some missing values. There must be some values, but in some scenario you find that there are some missing values in some columns. So either you have to delete the row or you have to fill the row. There are many techniques to fill the row, which we are going to study later. Okay, so all these things comes under dirty data. I'll show it to you using a data set. Now let's understand what is messy data. As I said, it is not an error. It is disorganized, poorly structured, like poor formatting, maybe mixed types in the same column, maybe there is a problem of standardization, maybe a data set having date columns in different formats. Date can have different formats. So in a single column, you have different formats of date. Then your algorithm will not be able to understand this. So there may be some standardization problem. You cannot say that this is an error, but this is a problem. Okay, this is needs to be fixed. So these things comes under messy data. Or maybe in the same column, you may have numerical values, you may have categorical values in the same column. So that will also create a problem. In fact, you have to convert any categorical variable to a numerical variable before you model. One hot encoding, label encoder, all these things are used to convert any categorical variable to numerical variable. These things also we will study later. Okay. Now next one, you may have some unnecessary data. Same, you cannot say there this is an error, but this is not necessary. So you may simply remove that unnecessary data. Or there may be some complex nesting structure. Okay, so you understand the difference. Dirty data means you have a problem, you have errors, inaccurate. But messy data means that is not inaccurate, but it is structurally not organized. Your model needs a properly structured, clean data set. Then only it will be able to give you the best result, best prediction. Okay, now let's see two data sets. I have taken two data sets to give you an idea about dirty data and messy data. We have already studied. Now let me run this first. Now let's explore this data set first. We will first watch this manually. See here, John, and again John. So you can easily see that the values are repeating same data points but multiple entries. So you can say that these are duplicates data. So you have to remove these duplicates. This is a dirty data. Otherwise, your model will not be able to give you proper prediction. Okay. Now next is the age column. It is looking fine. But suppose there are some values called 99 or 5 5 years, then you can easily understand that all these values have a mean around 30. Okay, but suddenly you get a value of 6 months or you get a value of 90 years, then you can easily say that there are outliers, so you have to remove the outliers. Okay, now suppose in this column I get one value O, maybe due to typing error. But you can understand that it has no meaning, so it is inaccurate. This is a wrong data, so you have to clean that data also. Okay, so you can say that there is a value called nan. That means there is a missing value. That is also a problem. Either you have to delete this value, or you have to find this value, you have to replace this, or you may need to create a new category called nan. There are many techniques, but you understand the data set may be dirty and you need to clean that data. Simple. Now let's explore this data set. Here we will understand what is messy data. See here, student name looking fine. But in details column, see in the same column, it has written math 85, science A. Instead, it may have given you a subject column. Okay. Or maybe there can be some changes structurally. Whatever it is, this is not suited for modeling. So this data is known as messy data because this data is not an error. This is there is no wrong in the data set, but this is not organized properly. You have to change this data set and you have to clean the data set. Fine. Next, see here enrollment date. See the format. This is the format, but here this is a different format. Again, a different format. So algorithm will not be able to interpret this. So you have to clean the data. You have to make them in the same format. Next one is grade. See here, some are numbers, but it is a category. So you have to change this category to a numerical value. Okay, we have to write code for all these things and we will do these things also. But as of now, we are just trying to understand what we need to do. Now, this column, I have written an unnecessary column. Maybe this column have no input in predicting the output. So we can simply remove the column. We can remove the unnecessary burden of the algorithm. You get my point? There is no error in the data set, but it is a messy data set. Okay, so either you have error or you have structural problem. You have to clean the data set for modeling. Okay, so in our later classes, we will do many examples and we will learn how to clean these types of dirty data or messy data. Okay, till then, bye. Happy learning. Hello everyone, welcome back to this channel. So let's continue our EDA session. In our last class, we understood how to clean any data set. If your raw data has any errors or any structural problem, then we have to clean the data set. Okay. We also understood what is the difference between a dirty data and a messy data. And if in your data set there are some missing values, then it comes under dirty data. You remember all these things? Now, in this session, we are going to understand if your data set has some missing values, then what can we do with those missing data set? First, we have to identify the missing data. Then, either we can delete those rows where there is any missing value, or we can replace the missing values with any other values. Okay, so we are going to learn all these things in details. First, I have taken a data set. This is a small data set where there are some missing values. None means missing values. Okay, now first our job will be to identify the missing values. Let me first show you the data set. So you can manually see that this is a missing value, 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 this is also a missing value. But when you have a large data set, you have to identify whether there are any missing values. If yes, then how many missing values you have. Okay. So first, to identify the missing values, I can write df5 dot each now. Okay. So you can see that false means this is not a missing value. There are some values. Not missing, not missing, not missing, not missing. True means this is a missing value. See here. See, this is a missing value. False, no missing value. Here is a missing value. See, missing value. Okay, so you understand that I want to know whether the value is missing or not. Here it is saying, no, it is not missing. But here it is saying, yes, it is missing. So you can understand that your dataset has some missing values. Clear? Now, these things we can do in other ways also. Like if I write df5 dot each null. Now see, same output. Or suppose if I write df5 dot not null. That will show me whether this is null or not null. See here, it will show you exact opposite. Here I want to know whether the value is not null. Here it will say yes, this is a not null value because there are some values present here. Let me show you the data set. You will be able to compare well. If I write df5 Okay, some values are present here in the index ID column. Okay, that's why true. Here, see in grade, here is also a value present, so it will be true. No value present, so it will be false. So you get my point. The difference between not null and is null is exactly opposite. Is null means I want to know whether there is a null value. So that's why the output is no, there is no null value. Here I want to know whether the value is not null. Yes, the value is not null. Okay, simple, just exactly opposite of each other. By any of these function, is null or is null or not null, you can identify that whether your data set has missing values or not. Okay, now I can see that there are missing values, but I want to know that how many missing values as per the column. So I can write is null dot uh, sum. Now if I run it, see, these are the column names. From here you can see that 0, that means no null value, 2 null value, age 2 null values, name 2 null values. So here you can see that in grade column 2 null values, in age column 2 null values, in John column 2 null values. Okay, I can also write df dot info. Here also you can see info means it will give you the complete information about the total data set. See, these are the column names, ID, grade, age, name. Here you can see total 5 entries. That means every column must contain 5 values, right? But here see, total 5 values, non-null. Because in the first column, ID column, there is no null value, okay? But you can see in grade column, there are 3 non-null values. That means 2 values are missing. Let me show it to you. BF5. See, if I run it, you can see in grade column 2 values are missing because here there are 3 entries, total 5 entries, but 3 values are non null. That means 2 values are null, so these values are null. In age column, same, 2 values are missing, 1 2. In name column, same, 3 present, that means 2 are missing, so 1 2. Fine. So from info function also you can understand how many values are missing. Okay, so now you have discovered that you have some missing values, and some will give you total missing values. Grade column 2 missing values, age column 2 missing values, name column 2 missing values. Clear? Now what can we do with the missing values? We have found that there are some missing values, but what will you do with them? We can simply remove them. Okay. Now suppose if I want to delete those columns, so I can write drop now. Drop now is a function which will show you only that row where there is no missing values. See the first one. Let me show it to you dataset again. If I run it, see only the first row there is no missing value. That's why it is showing us the first value. Okay. But you can see that this is showing an output. That means the change is not permanent. So I have to make the change permanent. I can do it in two ways. If I write df6 equals to df5 dot drop now. Now if I write df6, now let's see. Okay, so all those rows where there is any missing value has deleted. Only the first row is left because there is no missing value. Okay, so this way you can make the thing permanent. Okay, this is one option. And the second option is, let me first delete this one. And if I write df5 dot drop now, that means I'm in the last state. Okay, now I want to make the change permanent. This is not permanent. Let me show it to you that this is not permanent. See, because whenever you can see the output, na, there is no permanent change. Here you can see that there are some missing values. The data set is like before. Okay, now I want to change it permanently. So I can write in place equals to true. If I do this and see there is no output. Whenever there is no output, the change is permanent. If I run it, df5 has been changed. Clear? So in place equals to true means that I am instructing you, please change that and make it permanent. Don't return any object. Instead, you change it in the dataset itself. Okay, you get my point? Now suppose in some scenario you don't want to delete them. Maybe you have a smaller data set, or maybe other values are very important. Maybe small number of values are missing. There may be many reasons where you don't want to delete that. Instead, you want to fill them. So how can we fill them? How can we fill the data set where the values are missing? First, let me take that old data set. Here, if I paste and let's explore the data set again. Okay, so there are some missing values, and I want to fill those missing values. So there are many techniques to fill them. We will understand one by one. See here. First, we can fill them by mean or median or mode. You know three of them. Mean means the average value. So if I want to fill the age column by the mean value, then I have to make the average of them, and then I will fill these two missing values by the average of mean value. So I have to write df. I want to calculate the mean of this age column. So df age dot mean. Now what is the mean value? 5. 30. So 30 is the mean value. Now I want to replace these NaN values by 30. So I want this age column to be filled with 30. So I have to write df5 age column dot fill now. Then I will fill this using this one. So if I write it here and now if I run it, see this has been filled. Okay. Now if I check df5, what will be the output? What do you think? See, there is no change because I told you, you can see the output. That means the change is not permanent. So I have to write comma in place equals to true. Now see what happens. See, no output. Now check here. Okay, so you have done your job. Age column has no missing values. Okay, so we have understood the concept of mean. But sometimes, depending on how your data is distributed, whether normal or skewed, right skewed or left skewed, depending on all these things, you may have to select whether mean or median is best for filling the missing values. Okay, but whatever it is, we have understood how to fill it with mean. Same way, we have to fill it with median. So let me first bring the data set because we are changing, that's why I have to copy paste. But if you want, you can create a new data set by creating a copy of this data set. Then also you can make changes. Okay. But here I am just, our aim is to understand the things. So that's why I'm not creating any data set. DF. But when you are working with a big data set, just try to create a copy of the data set every time you make any changes. Okay. Anyway, let's see here. DF age dot median. Now if I run it, 5. Sorry, median spelling mistake. Okay, same value. Mean value, median value is same here. That means normal distribution. Okay, anyway, now if I write DA5 and I want, first let me show you that there are missing values. Okay, now suppose if I want to fill up that age column with median values. So I have to write dot fill now. Fill is a function which fills with the given values. Here I will give these values. That means whatever the median value is within fill na bucket. It is passed as a parameter. Clear? Now if I run it, you can see the output. So the change is not permanent. So you have to write in place equals to true. Now if I run it, fine. Now if you want to check df5, okay. Or if you don't want to give in place equals to true, then also you can do it, keeping it within another data set. Okay. Anyway, our job is done. So we have filled it with either median value or we can fill it with mean value also. Fine. Now suppose I want to change the value of grade. I want all those missing values to be replaced by the mode value. Mode means which is occurring most of the times. Though here A is occurring once, B is occurring once, C is occurring once. So if I write df grade dot mode, so you can see that um, most of the times, actually only 3 times, A is occurring once, B is occurring once, C is occurring once. Okay, but you know what is mode? Mode means that those values which are occurring the most number of times. Sometimes you may get that two values are occurring most of the times. Two of them are coming first. It's like that. Both have same roll number. Okay. So in that scenario also, you may face this problem. So I can simply select the first one. The 0th index, the first one. Okay, now I want to fill these missing values with this mode value. Fine. Same way, I have to write df5 grade dot fill na, and I want to fill with this value. So if I just write comma plus equals to true. Now if I run it, see the change is permanent. It will be filled with A. Clear? The missing values are filled with A. The same way, you can change the values in name also. You can fill up the missing values. Okay. Now, suppose I want to create a category called nan. I don't want to replace them with any value. Instead, I want a separate category named nan. Nan. Okay. So now let's see. First, let me bring that old data set. This one. Because I want more missing values. Where I have filled up the values. So now, let me show it to you again. Fine. There are some missing values. I want to create a category for them. Okay. So how can I do it? If I write df5 dot fill now, I want to create a dictionary. Grade I want to be filled with nan value. Okay. Now the age column, age I want to be filled with -1. This is also like there is no value. And next is name. Name I want to fill with uh, unknown. Okay. So in every data set, I'm not changing or I'm not replacing the values with a good value, but I'm replacing it with some other values. Like here, this one will be shown as nan. In age column, it will be shown as -1. In name column, it will be shown as unknown. Okay. Now, suppose if I run it, now see here, the values has been filled. In grade, nan, age column, -1, name unknown. Okay, so you are not deleting, you are not replacing with mean median mode, but you are replacing it with your own given value. Nan value, -1 value, unknown value. So you are creating a category of them. Okay, these are also you can fill up the missing values. But here also the change is not permanent. If you want to change it permanently, you can store it to some other data set. Create df6 equals to df5 dot fill now. Okay. Now if I run df5 again, you'll be able to see the old data set. Now, if I want to replace this value with forward fill and backward fill method, that means I want the missing values to be filled up with either the last value or by the next value. Okay, let me show it to you. df dot again fill na function, but here there is a parameter called method. In method, if I write ffill, now if I run it, it will be error because again df5. Now see. What happens here? There is no values but filled with A because it has taken forward fill method. F fill means forward fill. Okay. Here also 30. Here it will be Bob. See? Clear? Now suppose if I try to fill it, the change is not permanent. So I have that old data set. So no problem. I can simply write fill now function method equals to backward fill. Now let's see what happens. Let me show it to you df5. You will be able to compare. See here, this is a none value, but it has been filled with B. This is a none value, it has been filled with C. Here it is a none value, but it will be filled by 35. Backward fill method. Here it is not filled because it is not getting any value after this column. Next here, John, none value, it will be filled up by Alice. Okay. Here it will not be filled up because same problem. Okay, so you can fill by forward fill method or by backward fill method. So you have to use for A fill or you have to use B fill. Okay, so we have understood how we can delete, how we can replace with mean value, median value, mode value, how we can replace with nan value, nan category, or how we can use forward filling or backward filling. Okay, so these are the ways you can fill the missing values. There are some other ways also, like interpolation. Interpolation means based on some surrounding points. Let me show it to you in this data set. Just let me paste it. See here, the data set is about day and temperature. 7 days and temperature on each day. Here you can see there is a nan value. Okay. Now if I run it, here in this line, I am filling the nan values by interpolation method. Here method equal to linear. Linear means that linear relationship will be taken for filling up the values. It will fill the values using the surrounding point. So here see np.nan, the third one is filled up with 22.525. Okay, so its surrounding points are 21.5, 23. So if you calculate these two values, you will get 22.25. Here the surrounding point is 24.0 and 25.0. So if you calculate 24 plus 25, 29, 49. So it will be 24.50. Fine. Okay, so interpolation is done by the surrounding data points. You have to use the interpolate method, and here the method is linear. Linear regression, when we will study, we will understand this is nothing, just a linear straight line relationship. Okay, this is mainly used while doing time series analysis. In fact, forward fill and backward fill also mainly used when you are working with time series dataset. Because in those scenario, the previous value or the very next value matters a lot. So those time you have to use forward fill or backward fill. So depending on which type of data set you have and what you want to do with the data set, you will decide by which method you are going to fill your missing values. Clear? Now one more method, that is model based imputation. This one I will not tell you right now. Whenever we will learn modeling, that time we will understand how to do any model based imputation. Depending on which model you are using, machine learning models predict and fill the missing values based on other features of the dataset. Okay. So the last one is KNN imputation. This one also we will discuss later. Okay. So you have a fair idea about how to find any missing value, how to replace them or how to delete them. Okay, so we will meet in our next class. Till then, bye. Happy learning. Hello everyone, welcome back to this channel. In this session, we are going to understand how we can remove outliers from a dataset. This is a very important part of EDA because before you model your data, you have to clean the dataset. And if your dataset contains outliers, then obviously the model will not be able to understand the patterns. Okay, so in this class, we are going to understand what is an outlier, why do we need to remove outliers, how to identify those outliers, and how to remove those outliers. Simple. Okay, first let me read out the definition for you. Outliers are data points that differ significantly from other observations in a dataset. That means they are not usual observations. They are far from the mean value, far from the average value. They can be high or low compared to the rest of the data. Let me show you the data set first. This is the data set. Let me copy this and paste it here. Now uh, give it a name data 7, df7. This is the dictionary ID, age, income. I am just converting it to the data frame as we have done this many times before. Now if I run df7, this is the simple data set. ID column, age column, income column. Now suppose you can see that in income column, average 50,000, you can see near 55,000, but suddenly you get a data point which has a value of 300 or which has a value of 15 lakh, 17 lakh. So you understand that maximum values are lying near 55,000 or 60,000, but suddenly you get 2 3 data points which are far from the average value. Now if you simply model this data set, obviously your model will consider this one also, 15 lakh also, and these values also, and it will get confused and it will not be able to predict the best result. So simply we have to remove these outliers before we model our data set. Okay, so clear, you get my point. Now manually we have understood that there are some outliers. Now let's see it by code. If I write df7 dot describe function, now if I run it, It gives us the descriptive statistics. Count, that means total number of entries, 25 entries. This is the mean value. See here, mean value is 61,000. Standard deviation, standard deviation is also so much high here. You can see minimum is 300. 25 percentile, 50 percentile, 75 percentile, maximum is 17 lakh. So you understand the difference. 300 is the minimum value, 17 lakh is the maximum value, median is 54,000, mean value is 61,000. So you can simply understand that the data is not proper. The data has outliers. Okay, so this is the way you should think, that your data set has some outliers and you have to remove them. Okay, now let's see it visually. You remember while learning Matplotlib and Seaborn, we saw a plot named box plot from where we can identify the outliers from the dataset. Box plot, let me show it to you again. Box plot is like this only. It has minimum value, maximum value, Q1, that means lower quartile, 25 percentile, median, 50 percentile, upper quartile, that is 75 percentile. And the difference between Q3 and Q1, this blue portion, is known as interquartile range. Now, if your data set has some outliers, it may be shown here or it may be shown here. Okay. So, if we plot this, we can easily identify whether our data set has any outliers or not. Okay, so to identify this outlier, let's do the box plot. We will do it using Seaborn for now, but if you want, you can use Matplotlib also. So let me first import the Seaborn. Okay, now let's plot this. SNS dot box plot df7, and here give it income. Okay, now let's run this. See, you can get the 5 number summary. Tell me, this is minimum value. What is this? Maximum value. Q1, this value is Q3. This blue portion is interquartile range, and these are outliers. So our job is done. We have identified the outliers. Now we have to remove the outliers. So now first we will calculate Q1 equals to df7 income dot quantile 0.25. Now let me run this. Let me show you what is the value of Q1. Just let's check. 50,500. You can see it from here also. See, this is 25 percentile. That is lower quartile. That is what is known as Q1. Same value. Okay. So you can relate the things, right? Now we have to calculate Q3 value. Same here. Just copy paste. Change it to Q3. And here it is 75 percentile. So now if I run it, Q1, let me show you the Q3. Okay. If you want, you can check 60,000. Okay. We have got Q1 and Q3. Now our job is to find a bound, to find a lower bound and to find a upper bound. Then only we can say that those values which are lying lower bound are outliers. Those values which are lying above the upper bounds are also outliers. Okay, so you get my point. We have to find a lower bound and upper bound of the data set. Then other values below the lower bound or above the upper bound will be simply removed. Our dataset will be cleaned. Clear? So we have to find the lower bound and upper bound. Now traditionally we consider Q1 minus 1.5 into the interquartile range. I have not calculated the interquartile range. IQR equals to Q3 minus Q1. Let me run this. You can here also directly write Q3 minus Q1, but it will be better for you to understand. That's why I'll show you what is the value of interquartile range. This is the value of the blue portion. This portion. This is 9500. Clear? So now here we can write IQR. Traditionally, we calculate the lower bound in this way. Considering 1.5 times of this blue value and subtracting it from Q1. Okay, then we will get the lower bound. Now let's write the upper bound. Upper bound equals to Q3 plus 1.5 into IQR. That means this one plus 1.5 times of IQR. That will be considered as the upper bound. So once you calculate the lower bound and you calculate the upper bound, you can identify the outliers and can simply remove them. Now let me show you the value of lower bound. This is the value of lower bound. Okay. What is the value of upper bound? 74,000. So if there are any income which is below 36,250, that will be considered as outliers. If there is any income above 74,250, that will also be considered as outliers. Clear? DF7 income less than lower bound. Now let me run this first. See here, you remember this one was 300. So this is less than lower bound. That means this data point will be removed. Okay. Okay. Same way if you want to see, just let me show you TF7 income greater than upper bound. Now let me run this. See, two values 15 lakhs, 17 lakhs. These are above the upper bound. So my job is now to remove this data point and remove these data points. Clear? Now let's write the code. DF7 income less than lower bound, or because I will consider both of them, either less than or greater than upper bound, either less than lower bound or greater than upper bound. Let me keep this in brackets. For both of them, I'll simply remove these data points. Let me first show it to you. If I run it, see, this is also true, these are also true. So all these three will be simply removed. So if I write DF7, just let's see these three values, because this is below the lower value and this is above the upper bound. So all these three data points will be simply removed from the outliers. Now I don't want the outliers, I want the clean data set. So I can simply, if I change greater than equals to, that means I want all those values which are greater than lower bound, and I want all those values which are less than equals to upper bound. Now if I run it, but this is an OR symbol, so I want all of them. So I'll write and. Okay, clear. Now see the income column. 44, 45,000. Okay. So I'm taking all those values which are greater than equals to lower bound and less than equals to upper bound. Any values below the lower bound or above the upper bound will be simply removed. Okay, this is my clean data set. Now we have to keep it in DF7 cleaned equals to. I just want to save this data set into this DF7 cleaned. Okay. Now simply if I just run it, you can see the data set. Fine. Now your data set is ready for modeling. Same way, if you think that your age column has some outliers, so you can even if you want just in the data set add some outlier, then try to do all this procedure in the same way and remove the outliers from the age column. Clear? I hope I am able to clear the complete concept that how you can simply find the outliers from the box plot, from the describe function, and you simply just find the outliers by using interquartile range, then remove the outliers. Okay, now your data set is ready for modeling. Okay, and we have already understood that it may give skewed result, it may give distorted relationship, there may be problem with model accuracy. Those are the reasons you simply need to remove the outliers, because our model is just trying to predict the data from its patterns, and outliers will give you a complete unusual patterns which is exactly not required for the modeling. That's why we need to remove the outliers. I hope now the concept is completely clear. Now we will meet in our next video. Till then, bye, happy learning. Hey everyone, welcome back to this channel. Let's continue our EDA session. In our last class, we understood how to remove any outliers from a dataset. Now in this session, we are going to learn how to mitigate the effect of outliers. That means the outliers will not be removed from the dataset. Instead, their effects will be mitigated. Okay. Now, first of all, let me tell you what is an outlier. You already know outliers are those data points which are significantly different from other data points. They may be either very high or very low in comparison with the other data points in that data set. Clear? Now, in some scenario, you may need that outliers must not be removed. Instead, their effects can be mitigated. That may happen due to any reason. Like maybe the other features are important, or removing those outliers may create different kind of bias. So in those scenario, you cannot remove the outliers. You can simply mitigate their effect by applying log transformation. You know what is log transformations? Log transformations are very powerful technique to reduce the impact of outliers. If you apply logarithms on any numbers, that numbers gets reduced. So it can compress a range of values. When your dataset has some outlier, that means the dataset has a high range because the low value, the minimum value is very low and the maximum value is very high. So the range of the dataset is very high. Okay. So logarithms will make the range small, will compress that range. So the outliers will become less extreme and it will have less effect on the data set. Okay, so now let's learn how we can do this. Okay, now first let me create a data set for you. Import numpy as np, import pandas as pd, import cword as SNS. Let me run this. Okay, now I will create a data set. So write data 8 equals to, now I'll create two column. One is house ID. In the house ID, use a range value because I want to generate 100 numbers. So 1 to 101. Okay, now in the second column, price. So in the price range, I'll write np dot random dot normal distribution. I'll generate 300 mean value, 50 standard deviation, and 95 outliers. Sorry, 95 points, normal points. With that, I want 5 outliers. So I will write np dot random dot normal. Uh, make the mean value 5000, make the standard deviation 1000, and 5 outliers. Total 100 points. Okay. Now what I will do? I will concatenate these two data sets. So I can write np dot concatenate function which concatenates two values, and here. Okay. Sorry. Um, Fine. Now run it. Convert it into a data frame. So write df8 equals to pd dot data frame data 8. Okay. Now let's run it. Just check the data set. df8. See the price column. Okay, so you will get 5 values having outliers and 95 values are normal. Now, if you want, you can identify the outliers by creating a box plot, and interquartile range also you can use to check how many outliers are present in the dataset. We will not do this in this session because we already did in the last session. If you have any confusion, just watch that video. Okay. Anyway, we will do a KD plot here. KDE plot of the price column. So BF8 price. KDE plot we learned while studying C1 library. If you have confusion, watch that video. Anyway, give shade equals to true. Now see, you have outliers. Fine. Now let's apply logarithms on this. So I will write np dot logarithm on the df8 price column. Okay. Now if I run it, see. See, you can see the values. Here, the values, this has been reduced. Okay, the range is very small now. if you want, just let me keep it in df8 price column. If I write price equals to du stored here. Now df8 price column. Okay. Now if you want to check the describe, then you can simply write df8 dot describe function. Now see here, the standard deviation is very low. Mean value is 5.85, maximum is 8. Okay, earlier it was like, let me show it to you here. df8 dot describe. Now if I run it, sorry, it has been changed, so I have to run this again. Now if I run it, now see, the mean value was 504, the max value was 5538, the minimum value was 184, and the standard deviation was 915. Okay, so from here you can easily check that it has layers, but here I have to run the things again. Now see, the range has been reduced. Okay, see the changes in the mean value in the standard deviation has become less than 1, the maximum value. Clear? Now if you want, you can create a KDE plot on DFA on price column. So here I have to write set equals to true. Now if I run this, see it has also changed. Earlier it was like that only, more distorted, more skewed. Now it has been changed. Okay. So you can understand that without removing outliers, you can remove the effect of these outliers. Now, if you apply any model on this data set, it will be able to give you better results than before. Okay. So in those scenarios where you cannot remove the outliers, you can mitigate the outliers. But remember one thing, that if your data set is right skewed, then only you will be able to apply logarithms. If your data set is left skewed, then it will not give you a good result. Okay, you should not apply logarithms on that. Fine. Okay, so we have understood the things. This is a very simple topic. We will meet in our next video. Till then, bye. Happy learning. Hey everyone, welcome back to this channel. In our last two sessions, we understood how to identify an outlier, how to remove those outliers, or how to mitigate the effect of outliers using log transformation. Okay, now in this session, we are going to understand how to use Z-score to identify and remove outliers. First of all, tell me what is an outlier? Outlier means those data points which are significantly far from the mean value. Now, what is a Z-score? Z-score is a measure, a standard score. It measures how many standard deviation a data point is from the mean of the data set. Okay, so it calculates the distance of the data points from the mean in terms of standard deviation. Fine. How to calculate? Z equal to x minus mean by standard deviation. Mean means mean of the data set. Standard deviation means standard deviation of the data set. And x is any particular data point. Okay. So Z-score tells you how far a particular point is from the mean data. If that is positive, that means the data point is above the mean. If it is negative, the data point is below the mean. Fine. Now, after you calculate the Z-score, you have to create a threshold value. Typically, it is 3.0, but you can adjust as per your specific needs. We will see that. Okay. Now, after you calculate your Z-score, set a threshold, then you can flag the outliers. You can identify those data points which are outliers, which are not as usual. Now, you can simply remove them. Okay. Now, let's do it. First, I want import numpy. Now, from scipy dot stats import Z-score. If you want, you can calculate by yourself also. Simple formula, but it is already written, so we will just import this. Okay. Now create a data set. data 9 equals to np dot array, and within this we can write 10, 15, 20, 25, 30, 29, 40, 25. Okay. Suddenly I insert a point 5000. Then again I give 15, 17. Okay. So you can easily say this one is the outlier. You can check by describe function or by interquartile range also. But here our main objective is to learn Z score. Okay. So first we will calculate the Z score. So Z score equal to Z score of data 9. Exactly. Now run it. What has happened? Oh, I'm so sorry. Now fine. Now let's see the Z scores. Distances from the mean minus 0.32. Almost same. Almost same. But this one, see, 5000, 3.16. You can see that it is far different from others. Okay. So you can easily check here that there are outliers. Anyway, you may have a weak data set. Here we are working with small data set. That's why we can easily identify. Anyway, now I will give a capping. So I will set a threshold value. Okay, so let's write outliers threshold equals to 3. Typically it's 3, 3.0. Now let's find those data points which are greater than 3.0. They will be outliers. So I can write np.abs. Abs is a function. You can say absolute function. It calculates the absolute value. So z scores greater than outliers threshold. Exactly. Only those values which are greater than 3.0. This is false. All of them will be false. Only this one will be true. Fine. So I want only these value as an outliers. So I can simply write it outliers. Fine. Let's print it again. Okay. Okay. Now let's visualize this. I can write plt dot scatter. Scatter plot, you remember, shows the relationship between data points. Now I have to write a range because I want to generate a range of numbers for x coordinates. So length of data, oh sorry, data 9. Okay, this is the x point. What is the y point? Y point is data, data 9. Okay, fine. So x point, x coordinates we are generating, and y coordinates are the data 9. Now let's see. See here. This one is outlier. Okay, x coordinate, y point. The outlier is almost near 5000. Oh, no, it's exactly 5000. So it's the outlier. You can visualize this way. Fine. Now I want to simply remove them. That means I want only these data points. So I can simply write filtered data equals to data 9 outliers. That means remove the outliers and keep all the values. This does exactly opposite. Okay. Now let's run this. Fine. Now let's print this. See, there is no 5000. Okay, so you have done your job. Now let's do one more thing. I add 7000. Now see, both of them are outliers. So both of them must be removed. Let's see what happens. Let me run all these values. And you can see two outliers significantly different from others. So here you can see, no, these are not removed. Why is that so? You try to think. If you can't, no problem, I will tell you. Check here. This is the value of 5000, 1.75. This is the value of 2.64. So these are the distances. But threshold is 3.0. So they can match the criteria. So that is why it's simply not removed. So now if you want, you can change the threshold value. You can give 2. If you want to remove 7,000 only, you can give 1 or 1.6. Any value below 1.75. So if I give 1.5, now check. Now if I run this, then 5,000, 7,000, both of them will be deleted. Okay, say both of them deleted. Clear? So typically it is 3.0, but if you want, you can change. So this is the way you can use Z-score and remove your outliers. Okay, so you can remove by IQR, you can remove by Z-score also. Okay, now I will give you a homework. Tell me when it is better to use Z-score and when it is better to use interquartile range. Okay, let me know this by comment. If you don't know and if you want to know, then also let me know. I will explain you in my next class. Okay, so meet in our next class. Till then, bye. Happy learning. Hello everyone, welcome back to this channel. So we are continuing our EDA session and we are doing data cleaning. As of now, we have completed how to handle missing data, how to handle outliers. Okay. Now we are going to learn what are the other things we can do while doing data cleaning. Okay, let's learn one by one. First one is dealing with duplicates. Duplicates means the same value repeating. So we have to delete this, otherwise this will create a bias. So first we have to detect the duplicates, then we have to remove the duplicates. Let me first copy this data set. Copy, paste. Now let's run it. Change it. Let's give what was the data set the last time I used data 9. So we can simply write data 10. Okay. So here df10 data 10. Now see this data set has duplicates. 0, 101, A1, quantity 250, order date. In the second also same values. Okay. So in this data set we have duplicates. Now, how to check whether there is any duplicates or not? So I will write df10 dot duplicated function. Now if I run it, you can see this one is true. So we have to simply delete this. There is no other way. Now I can write drop underscore duplicates. Now if I run it, see unnecessary duplicates are deleted. Now suppose I want to delete the first one, the zeroth index, not the second one. For that, I have to write keep equals to last. That means please keep the last one. Okay. So 0 is deleted, 2 is there. Okay. You can write keep equal to first, but by default it is first. If you want it to be last, and then you have to mention keep equal to last. Okay. So you have learned how to detect duplicates, how to remove duplicates. Now let me show you one thing. Let's say here I change the quantity to be 3. Now it's not a duplicate because one value is at least different. Now if I run it, the quantity is changed. Okay, no, it doesn't have a meaning, but for understanding now, I have changed it here. That means it is not duplicates. If I run it, it will show false. Fine, no problem. But I want that please ignore the quantity. If the rows are same for customer ID, product ID, price, order date, if the values are same for these columns, then treat it as duplicates and delete it. Ignore the quantity column. Okay, due to any reason. So for that scenario, I have to write, first let me run these things again. And now there is no duplicates. Okay, let's run this one also. No duplicates. So that's why nothing deleted. But now I will delete dot drop underscore duplicates, and here I'll write subset equals to. Okay, now here I will keep only those columns which I want to be considered. So I will let's copy this and paste. So I want customer ID and I want product ID. So I can write product ID. Then I want price. Okay. So on basis of these three columns, I want to check whether my data is duplicates or not. If duplicates are here, then only drop the duplicates. Else don't. See here, the dataset is dropped. Though the dataset was not duplicate because quantity was different. But here I have specifically mentioned that ignore the quantity column. Take only these three columns and check if the values are duplicated. Here these values are duplicated. So these have been deleted. Clear. So this way you can create subset also, and based on that also you can delete the duplicates. Anyway, you have to delete the duplicates. Fine. Now let's understand the next one. Correcting the data types, because sometimes the data type may not be correct. Let me show it to you first. Dot D types. See here, there is a column called order date, but this is object data type. But I want it to be date time data type. Then only I can perform some date time functions. So in that scenario, I can simply write pd dot to underscore date time df in order date. So it will be converted to date time. Let me show it to you. df10 dot d types. D types function shows you the date time column. We are learned it while understanding discovering of EDA. Okay. No, it's not done. Why is that so? Oh, because the change is not permanent. I told you many times before. So you have to keep it here equals to. Now see. Okay. Clear. Now let's understand. Uh, Suppose I want to change the price column from integer to float. It is an integer, you can say, but I want to change it to float. So I can write df10 price column dot as type, change it to float. Okay, so it will be changed to float. Okay, but the change is not permanent. You have to keep it in df10 price column. I have to copy this, paste equals to. Okay, now if you check, let me show it to you. df10 dot d types. Now you can see that the price column has been changed to float, or the date column has been changed to date time. Okay, this is also part of data cleaning, because otherwise you can perform some operations on this. So depending on your need, you have to make this conversion. Okay, now standardization. Suppose in this column df10, here the product ID is in caps. Now suppose due to any reason I just want to change it to lowercase. So I can simply write df10 in the column name price. Here I have to use str.lower. Str, we learned all these things while studying string in Python. Anyway, this is simple. But oh, not price. I'm so sorry. We are doing on product ID column. Product ID. Price is a numerical number. Okay. So you can change. You can upper UPP here, then it will be into uppercase. You can write swap, then uppercase will be in lowercase, lowercase will be in uppercase. Okay. So these are the way you can uh, modify your data. Fine. Now let's do how to handle erroneous data. If something is wrong in the data set, let me first copy this data set. Just paste it. And let's name it 11. Okay, I have to convert it. TF11 equal to PT dot data frame data 11. Now let's run it. Now again write TF11. Okay, now see here, age minus 3, minus 5. You can easily say that this is not possible. This is erroneous data. df11 dot lock. Here I write df11 age less than 0. I'm giving a condition on the age column, then make it a NaN category. You see, let me show you df11. See, it has been changed into NaN category. Okay. If you want, you can replace it with mean value also. So I have to write df11 exactly age dot mean value. Now see, it will be uh, sorry, df11 has been changed, so I have to run them again. Now see, changed by mean value. If you want, you can change by median value. Same, we have to run it. Otherwise, it won't be able to find the uh, this condition. It will be not be able to match this condition. So it will be changed with median value. Okay. You can change it with mode value. Okay. So as per your wish, you can simply change, because here you can see that these are not possible. So either you have to create a category or you have to change it with mean, median, mode, or any particular value. If you want, you can change it. Okay. Now next one is replace. Let's understand the replace function. Suppose I want to replace, let me first copy the data set and this one give 12. We can here make it 12. Okay, let's check df12. Fine. See here, these are in dollars, but I don't want this. I want only the numerical values. So I can simply replace it. So I can write price dot str dot replace it with nothing. Okay, once I run it, see, fine, this change is not permanent, you have to keep it in df12 price column. Okay, if you want to change the data type, you can change the data type also. When it is object data type, you can make it integer or you can make it float by writing as type function. These are the methods by which we can do data cleaning. Okay, in our next class we are going to learn about data joining. Till then, bye, happy learning. Hello everyone, welcome back to this channel. So let's continue our EDA session. EDA has 6 processes and as of now we have completed discovering, structuring and cleaning. Now let's understand data joining. That is joining multiple data sets. Okay. Now data joining can be done in two ways. One is merge and another one is concatenate. In both cases, you are joining two data frames. But when you are joining them based on a common column, this is known as merge. And when you are joining them along axis, along rows or along column, then it is called concatenate. Let me show you the examples, then it will be crystal clear. Let me first copy this two data set. Both of them are simple clean data sets. Let me show it to you. First one, I want to make it 13 and here I want to make it 14. Now let me show you df13. If I run this, see student ID, name, grade. Simple clean data set. df14, student ID, sport. So the common column is student ID. Now I want to merge these two data sets. I can do it in different ways. Let me write it first. So I want df13 dot merge with df14 based on student ID column. Okay. Now if I run this, see 1, 2, 3, because here 1, 2, 3 is present. Here also 1, 2, 3 is present. 4, 5 and 6, they are not present in both of the data sets. That's why they are simply ignored. But if you want, you can do how equals to left. Sorry, how equals to left. Okay, now if I run it, see. Now see 1, 2, 3, 4, 5. That means the first one, df13, 1, 2, 3, 4, 5. This one is in the left. So this one is prioritized. So I have taken all these values 1, 2, 3, 4, 5. But here 4, 5 is not present. So sports column will be missing. See here, there is a NaN category. Okay, and 6 is simply ignored because 6 is not in DF13. Now suppose if I change it to right. Now can you tell me what will be the output? This is simple. Now I am prioritizing the this one, the right table. Okay, so here I will take 1, 2, 3, 6. This one will be compulsory. Sports will be there. But from here it will take 1, 2, 3 student name and grade because these are matching. But 6 is not there. So 6 will be here NaN value because 6 is not in this data set, in this left data set. And 4 and 5 will be simply ignored because here we are prioritizing the right table. Now if I run it, let me show you the output. Okay, so 1, 2, 3, 6. And as this one, these are not present, so these are NaN. 4, 5 is ignored because I am giving how equal to right. If you write how equal to inner, then it will show you that first output, the common ones. Okay, so you can do left join, you can do right join, you can do inner join also. So these types of merge you can do, but these are based on a uh, common column. Okay, now let's understand what is concat. Now let me copy these two data sets. Um, one is data grades and data attendance. Uh, just let me paste this one. So here I'll name it 15 and I'll name it 16. Okay. Now if I run it, let me show you the data sets first. DF15, DF16. Okay. In the first one, student name, math, science. Here, student name, attendance. Now I want to concatenate them. So I can write pd dot concat df15 df16 and axis equals to 1. Now let me show you the output. See, Alice, Bob, Charlie, David, Eva. Alice, Bob, Charlie, David, Eva. Here it is math, science, attendance. Math, science, attendance. See here, student name is 2 times because here we are not joining based on any common column. We are just joining the two data sets. That's why student name is present here also. Student name is present here also. Like if I simply delete this one. Now let me run this. So DF15 will be student name math science, but in DF16 there is only attendance, no common column. Now if I run it, see they are joined. Student name math science attendance. Okay, you get my point. So here merge is based on a common column, but concat is not like that. It is simply joining. And I in that scenario we have already seen that student name is repeating. So what you can do, you want student name to be appear once. I have to write df16 dot drop inside columns equal to, I want to drop student name. Now if I run it, let's see, student name column is deleted. So simply I can just copy it and I paste it here. Here. Then what is happening? After it has been dropped, this one is remained. This one is joined with DF15. Now let me show it to you. Clear? So this way also you can join. You just dropping the student name column from this so that it doesn't appear twice. Clear? Okay. So we have joined column wise. Now let's understand how we can join row wise. For that, let me copy this one. And I want to add one more new student. So I write date data about a new student. Okay. Now here student name I want to give Mary and delete all this. I want to add only one new student and the attendance is 99. Good student. Okay. Now write df 17 equals to pd.data frame data new student. Fine. Let's run it. Let's check df17. Okay, so Mary 99. Okay, so df16 is let me show you df16 also. df16. df16 is Alice, Bob, Charlie, David, Eva, and their attendance. In df16, Mary and her attendance. Now I want to add this too. So I have to add row wise because I want it to be here only after Eva. So I can simply concatenate pd dot concat, concat, and I want to concat df16 comma df17. Fine. Here I have to mention x is equal to 0. Okay, x is equal to 0 means row wise, x is equal to 1 means column wise. Okay, you can simply say Mary 99 added after you. Okay, so as of now we have understood how to merge. Merge is based on any common column, that may be right join, left join, inner join, and then we have understood concat. Concatenate means there is no common column, and if it is there you may simply remove it by dropping the columns. Anyway, you can add it column wise, or if you want you can add it row wise depending on your need. Okay, so we have understood how to join data before you model your data set. Okay, so meet in our next video. Till then, bye. Happy learning. Hello everyone, welcome back to this channel. Let's continue our EDA session. So as of now, we have completed discovering, structuring, cleaning, joining. Only two things are left, validating and presenting. Okay, now what is validating? It ensures that the data meets the expected quality. That means the data must not have any inconsistency, any error, or any kind of anomalies. Okay, so simply you have to make sure that your data is valid. After you do any step like discovering, structuring, cleaning, you always have to make sure that the data is valid. Okay, now here I have written some techniques for validating the data while doing EDA part. It's your job to do these things because all these things are already discussed. You can calculate the mean value if your column is numerical, median value, mode value. You can check the distribution like normal or something else. By this you can understand whether this column is valid or not, right? For categorical column also you can check the mode value, and you have to make sure that this column is valid. For date time column, sometimes you may need to change the data types. Okay, if missing column, then you have to fill the missing values by something else. If duplicates is there, then you have to delete the duplicates. If any kind of merge is needed, then you have to join, concat, merge. If any kind of structuring is needed, then you have to do all these things. So after you complete all these steps, you have to make sure that the data is valid. There is no error, no inconsistency, no anomalies before you model the data. So it is your job to do all these things. If you find any problem, then let me know in comment section. Okay, try to get the standard deviation value, the max value, the mean value. Try to find the range of the data set. Try to find whether there is any outliers or not. Okay. All these things are used to check whether your data is valid or not. Okay, you can check the normality also. Okay, you can check by p-value also. Okay, so this is your job to do this part. Next one is presenting. Presenting means communicating your findings, right? Like whatever is there in the data set, whatever hidden patterns, findings, you have to share it to your stakeholders. How will you share? Obviously, you will use some graphs, plots, then only you will be able to tell that these are our findings. These are the things can be improved. These are the measures we can take. Okay. So your suggestions must be presented to the stakeholders. Okay, so how can you do this? By different kind of data visualization techniques. These things also we have done while doing matplotlib and cmod. We did scatter plot, line plot, heat map. We found the correlationships by heat map. Okay, so all these things comes under presentation. You make a summary report and you highlight the findings. See here, one data set is taken. And here first histogram for math scores, then box plot. You can find outliers. You can understand what is the five summary value. Then scatter plot. You can understand the relationship. Then bar plot, you can find the frequency. Pie chart, you can find the percentages. Heat map, you can find the correlationship of different variables. And pair plot, in a single plot, you can see so many charts together and you can find the relationship, how they are correlated. Okay, so all these things we have done in details in our visualization classes, like in Matplotlib and C1. Okay, so we are not going to repeat these things. It's your job to do all these things. Take any data set and try to do as many kind of map as possible. Okay, so we have finished our EDA. This is all about EDA. We have understood how to explore the data set, how to structure, organize the data set, how to clean the data set, how to handle missing values, how to remove outliers, how to mitigate the effect of outliers. Then we understood how to join the data set, how to join based on a common column, how to join row wise, how to join axis wise, column wise. Then we understood how to make sure how to validate the data and how to present the data. Simple. We have completed our EDA part. And once again, these are no fixed steps. Any step can come after other step. After you try to present the data, you may find some patterns. You may think that you need some cleaning part. So you may go back to cleaning. Okay, all these steps occur in a circle. Any step can come after any other step. Your main aim is to make your data clean and ready for modeling. So we are done with the EDA part. Next we will understand what is feature engineering. Okay, till then, bye, happy learning.